We got through a lot of the problems we needed to solve, but the last one is going to be more of a sticky wicket, right? This one is we need to know where the local applications are. So Maya, Nuke, Houdini, where are they on this particular computer? And we've seen already that different computers, even with the same programs, even with the same major versions installed, might have the software in a different subversion, different folders, different paths. And of course, we also have the whole complication of different operating systems and file path approaches in terms of the slashes to worry about. So really, the most efficient way of handling that is to be able to store a file on each computer that is a configuration file, a config file, that will basically be something that we know we can easily access, read, and get information out of. And in each computer, we can just install that file and make sure that the various paths for that computer to each application are stored in it, so that in a format that we can read. And so what we're going to do is use a utility called ConfigParams. Um, it's a it's actually the module for Python is called ConfigParser. So before we get into the Python side of things, let's take a look at a config file itself so we can get an understanding of what's going on. So a config file is just a text file that is broken up into sections and then values, right? So this section is called system, and it's OS equals OSX, GPU count equals 1. This is just hand typed text, right? So I can put anything I want. Overall, the basic format is that sections are denoted by these square brackets around text, and there can be spaces, system information, etc. Um, and then there's values, and the value name is separated from its actual content by a separator, and this can actually be equals or the colon symbol. I tend to use equal signs. I mean, this file format has existed since like DOS 1 or something like that, back in the 1900s. So it's relatively universally recognized. It's just text, so you can move files around. One note, I guess, in saving these files is if you're on a Mac, you'll probably want to make sure that you try to use line breaks that have carriage return and line feed turned on, right? So I'll put that on there and save and replace. And basically, that's an important aspect of the different operating systems. It turns out that for the Macintosh or Unix, really, Unix-based operating systems, and you'll see that it says Unix LF. A new line is designated by a special character called line feed LF. It's an invisible character, and it's just a character that triggers a new line to start up. Okay, so that's straightforward enough. The thing is that on Windows-based operating systems, which evolved from DOS, they use a carriage return and a line feed. So carriage return in the old typewriter days would bring you from one end of the typing all the way to the beginning, and then line feed would advance the paper to the next line. So Windows use both of those. And yeah, by the way, I am still at home recording these, so you might hear some things in the background. But here we are working on the weekend. So anyway, we're going to make sure we save our files with the control line feed here for a Mac. Now, we'll get control line feed automatically on Windows, so that's nice. It doesn't really matter on the Mac, but on Windows, if we were to open this file with just the line feeds, you'd just get one long line of text and you wouldn't see these new lines. Okay, so we now understand that a config file can be saved and it's just text, and we have square brackets designating a section, and it's followed by value names with a separator like the equals, and then an actual value. So our interest is in creating a section, and you can call it whatever you want. For my purposes, I decided to create a section in my config file called apps. I actually don't need this information, by the way. I just put it in here just as an illustration so you could see how a config file with multiple sections would work. What we're really interested in is being able to save a text file that tells us where is Nuke. Where is Nuke X? Ideally, we'd have more like Maya and Houdini and things like that. I don't have those installed on this computer, so we'll just work with Nuke and Nuke X right now. So here's the path on this particular computer to the Nuke executable. Now on a Windows machine, it's pretty easy to find. You would just go into your program files and you'd find your Nuke folder, and inside there's probably a Nuke, 10 or 11 or 12, whatever version it is, .exe. Now on the Mac, it's a little bit different. So if we go and look at our Finder here and start a new window, we'll go into Applications, and then here we are at Nuke. I'll just go into these. I kind of prefer the column view. All right. So here's where the applications appear to be, but it turns out the way an application is stored on a Mac is a little bit different. It looks like these are files, but in actuality, they're very special folders. And so our actual executables, if we wanted to run them from the command line, are contained inside these special folders. And to reveal them, we just use right mouse click or control click to not open, but rather show package contents. These are called packages, and they really work just like folders. So we're inside Nuke 10.5 v5, and in there's a folder called contents, and there's a folder called Mac OS. And so this is really all the executable information, all the libraries and everything that make up Nuke. And right here, Nuke 10.5 v5, that is the actual file that we're running on a Macintosh. So if we wanted to run that at a command line, I can right click and get info. And that'll let me copy. If I just select this where, I'll select all of that, copy that, and go to my terminal, and I'll just paste that, right, Mac OS, and then slash, and here it is, Nuke 10.5 v5, all right? So if I hit enter now, we should actually launch Nuke. There we go. We're getting information about Nuke running, and it fires up. Okay, so I get my little license warning, and I can launch it if I like. A lot of times I'm just going to hit quit just for the sake of moving on with the tutorial, but just to show that it fully launches, that's there it is. That's really nice. Okay, quit. Incidentally, if I wanted to, I'm in this folder show shepherd, right? And if I ls, I can see that I've already saved a test composite, and it's a Nuke file, right? So if I got up arrow, and that gives me my Nuke command, I'm still inside my show shepherd folder. So I can just start typing test and hit tab to bring that up. And so now I'm running the executable, plus I've added a file name of a script that I want to open up. So I'll hit enter, and that'll launch Nuke. And not only will it launch Nuke, but it'll also open the file that goes with it. So in that case, it'll be the testcomp v01. So we're almost running. There's our dialog. And of course, there we are. All right, so here we are, testcomp. It's loaded up. And I just have color bars that are HD. So that's nice. All right, so that's how that works from the command line. And so all I did to set up my config file was copy that path, this applications, all the way to the end of 10.5 v5. And I put that as a line here. So I have a section, apps. I have a value that's named Nuke, and then equals, and then here is that path. Okay. And just as a final follow-up here, if we go back a few folders, Nuke X right here on the Mac, and I think there's a separate executable for that, or an alias or something like the shortcut in Windows that you would use. But on here would show contents, and right here, Nuke X. And so this is what you would use to run Nuke X. I can close these now. And I just copied those full paths. So the information is here now in this file, and I've saved it, and I gave it a name, SS for show shepherd, config.txt. Okay, and I've saved that into my home directory documents show shepherd folder, right? So what's nice is last time when we looked at our little foo experiment, let's go back to Text Wrangler here. We look at foo. We used this little os.path expand user tilde, and that gave us our user directory. And what's convenient is the user directory on both the Mac and Windows contains a folder called documents. So we could reasonably expect that on a standard install that we would be able to retrieve the home directory and find a documents directory inside that. So for our purposes, we can also place a show shepherd folder in there, and that's where we'll keep our config.txt file. So we'll be able to go and retrieve that without having any special configuration, right? So that we want to take advantage of. So what we need to do now is start working through reading in this file and using its values. So let's play around with foo to do that. We have find home path right here. So let's just define a new function. We'll define, call it run nuke. All right, and maybe at some point we want to pass it some arguments, and so we'll just call that params. And by default, we'll just give it a default value of nothing, right? So I'll just put in params equals, and then two quotes next to each other means it's an empty string, and then colon. All right, so that defines our function. And as a status check to make sure it's working, we'll say print, and let's run nuke. All right, and so then I can put run nuke here in my main application for foo. And see, this is nice because now I've changed the functionality of foo. But by the way, hello pi would still import foo and run normally, and it would still be able to run the find home definition. All right, so let's just try running foo here. So up arrow until I get back to my Python foo, and I hit enter. This is running a script, sure enough. And let's run nuke. All right, sounds like a good idea. So what we're going to do to be able to read the information in this text file is use a new module we'll introduce here called the ConfigParser. So I'll import and type in the word config and parser. All right, so ConfigParser is a module specifically designed for reading files like this. All right. So what we'll do is, first of all, we'll now here's an interesting thing. We might continually use this home path all the time. So maybe it'd be more efficient for us to define a variable that's valid for the entire module that would let us know where the home directory is. So I'm just going to copy this text. Right after our imports, I'll declare a variable called home dir, and I'll just retrieve it using this command. Now, the variety of sections of information in code in our script is getting a little bigger. So let's start dividing things up so we can spot which sections we're in. So I'm going to put in a comma or comment with a whole row of stars here. And that's going to designate for me that in the code, this is the start of a new section. And I'll just call this import modules. And then I'll just copy this line, triple click, copy, paste that right in there. And this section will be declare variables. All right, so these are variables that we'll need and we'll use. So home dir is going to get declared, and this is before we've done our little name check, right? So this will run every time we start up foo or import foo, and then we can use this variable anywhere that we need to know where the home directory is. So I can put that right in there. Okay, so let's run nuke. So we first of all need to create a config parser, right? And then we'll want to open the file. So I'm just going to create a variable here in run nuke, just called cp for config parser. And I'm going to say that that's equal to, there's a function. Now, really, search online Python config parser, and you can find full documentation on this. Done that ahead of time, so I'm just going to say config parser dot config parser and brackets. So basically, this is the command in the config parser module that creates a configuration parser object that will be able to process our file for us. And I'm putting that parser into the CP. All right, so now I can do things like open the file, right? So first of all, I want to find out where that file would be, right? So let's actually do that even before we create the config parser. We think that it should be let's say we'll say config path, and we'll say that equals, and we're going to use the same thing, os path join, copy. And this is great because we're os path join home directory. We've got that already. We know we want it to be in documents and show shepherd. And then we'll just say comma and we'll use our name, ssconfig.txt, ssconfig.txt. And of course, that needs to be in quote. All right, very nice. And for now, we could just do a print this config file, space that, and plus config path. All right, so we can save that. We're going to run this, and we should just be able to see what the path is. Sure enough, this is the config file. All right. Now, this right now, is a good place to start, what we call bulletproofing our code. We want to make sure, even though we've derived this and we think it should be there, it's possible that it might have been deleted since the last time we used it, or whoever's using show shepherd didn't really put that config file there. So what we can do here is just test if that file exists. So if os.path is file, right? And we'll put in that config path. If it is, then we're going to move on. So we really don't need an else in that case. What we want to do maybe is just immediately get cut to the chase if it's not a file. Now in the past we've talked about if equal equals. So if name does equal main, or I'm sorry, name double equals main, we continue. That's true. This file, if it does exist, we want to keep on working. But if it doesn't, we need to take a special action. We want to report, hey, that config file doesn't exist, and we can exit out. So what we will do here is right now, if the file does exist, this returns true. So we want to put a not in front of that. So if not, this is true, then do something. All right. So we'll just say print and say config file not found and exit. All right, so now we've double checked our user to make sure that even though we didn't ask for anything, we expect that the config file will be in this spot. And if we don't find it there, we want to exit out right away. So then we'll create the file. I'm sorry, create the config parser. And then there's a function in there in CP now that is for reading the file. So we can say cp dot read and then our config path. And that should read in the file. Now, if we want to continue bulletproofing our code, we might want to try around that tab and say accept and print to read config file and exit. Of course, our exit is actually part of the sys module, so we want to put in sys as another include right up here, and then make sure we do sys.exit and sys.exit. All right. So we've got some code going here now. So let's say, by the way, we'll probably want a little comment here saying that let's say that these are our functions. We'll say this is define functions, and down here, and this will be our run the script include. All right, and maybe we want to put comments here, like saying this just says hello. This is a test, and this runs Nuke. Okay. So we checked the file exists. We tried to open it. We've got it. So if we get this far in our code, the file exists, and we've opened it and read it into our CP object. So now we can try to see if we know where Nuke is. So what we can do is say try. Yeah, let's say try. And we'll say cp get. Right, because we want to get something out of that cp file. And that section that we saved in is apps. And the value that we want is Nuke. So that should get us our Nuke path. And we can git path to Nuke. And Nuke path. And of course, we do our accept. So steal it from here. And find Nuke in config file. All right. So that's pretty good. So we can, let's at this point just save this and give it a try. So we're going to go in, we're going to see if Nuke exists and see its path. And we can find Nuke path in config file. So let's see what we did wrong there. And just double check here. I've got section called apps and lowercase nuke equals this, and that is saved. So the config file was found, but we couldn't find, oh, fine, haha. So let's go in here and say couldn't find Nuke instead of couldn't find Nuke. And so this failed. Apps Nuke. Well, in theory, that should have worked for us. So what failed? Let's see if we can force an error by getting rid of our little try here. So in theory, if this doesn't work, hopefully we'll actually get an error. Save that. Nope, didn't get an error. Interesting. Aha, there's the failure right there, doofus. Right, I tried to get, I got the value, but I didn't actually put it into my variable name. Nuke path. There we go. Nuke path equals that. Now we should be in good shape. All right. Save our foo. And very nice. There's our path to Nuke. And just for an experiment, I'm just going to delete one of the letters for the name of our little variable. We'll save that and run it. Nuke, sure enough. All right, let's say we'll have Nuke in here, but I'll change apps to save. Should get that same error. And find Nuke. So it only works if we have a section named apps and a value in that that's named Nuke. And when we do, save that, we run Python foo, we now know where Nuke lives. So all we need to do is launch that. So we can finish this up by going into our foo. And at this point, we can use a module called subprocess. So subprocess. And I highly encourage you to take a look at searching documentation and tutorials on each one of these modules so you can learn more about them. The main thing that we're going to use here is the call procedure. So we're going to say subprocess call. It likes square bracket inputs. So we're just going to say square bracket nuke path. Close that. Let's see if that works. We'll save that. Crossed. We should see Nuke launch. Look at that. So Nuke is launching very nicely. We'll get our little thing, and I'm satisfied that it works, so I can go ahead and quit. So the nice thing that we really love to do at this point is be able to have Nuke open up a file that we pass as an argument, right? So let's say that we've already got sys, which we know contains our arguments. So we'll go to the very end of this space in here, and we'll give it a parameter of sys argv, because that's we know from previous classwork that that's what the arguments are. So params, nothing. Let's just replace this now instead with argv. Right? So we're expecting a list of arguments every time we come in here. And ideally, we know that the first argument, argument 0, is just going to be the name of the script. So the expectation is that the very next argument would be our Nuke file path, or the Nuke file that we want opened. So we'll just put that right in here as argv, and that's one to the next one there. So we're calling Nuke path, comma, argv. And again, the way subprocess call works, it needs the executable and then the argument in separated by comma inside square brackets. So let's give that a shot. Now we'll go here and again just do a quick ls. So there is my comp file. So copy. Go to get our foo command. I'll paste in. So now this is argv0. This should be argv1. And we run this. Ideally, Nuke launches and opens our file. We'll go ahead and launch this time because we want to make sure that it does indeed open our file. And it does. All right, so that is solving quite a few of our problems. So our next video will get into more about implementing this in a full-on show shepherd scripting situation. All right, have fun.